Let's just see how we might solve one of these equations using the identities, the functions we've just met, the reciprocal trig functions. So we notice here I've got 3 tan squared theta minus 5 sec theta plus 1. This should remind you of questions where we had sine squareds and cos squareds at AS. We're going to use the identity to change tan squared theta into sec squared theta so we can view this as a quadratic to be factorised. If you can't remember the identity, you can quickly derive it anytime. We know that to get tan squared and sec, we'll need to divide through by cos. So dividing through by cos here is going to give you 1 plus tan squared is sec squared. A quick little derivation like that, just to remind yourself if you can't remember. Substituting that in, we get 3 tan squared is equal to 3 lots of sec squared theta minus 1 minus 5 sec theta plus 1 equals 0. Expanding and simplifying that, we get 3 sec squared theta minus 5 sec theta and minus 2 equals 0. Factorising this, looks like it should factorise. 3 times 2 gives me 6, and 1 more I can get to there. So I have a minus 2 there, that will give me minus 6 sec theta. So I need to add 1. Factorised, I can see from here that sec theta is equal to minus 1/3 or 2. Thinking of the graph that we saw of sec theta before, we know that it goes from 1 upwards and minus 1 downwards. I can ignore that. Sec is the reciprocal of cos theta. So cos theta will equal a half. At this stage you may have also said cos theta equals minus 3, the reciprocal of minus 1/3, and you may have rejected that, the solutions there at that stage. Now we'll solve this for 0 to 2 pi. Inverse cos of a half, you should recognise this by now, but maybe not in radians. That tells us that it's pi over 3. Pi over 3 is equivalent to 60 degrees. Really try to remember these standard results, it just speeds up your work so much. Also, it could be 2 pi minus our answer, so that 2 pi would be 6 pi over 3, take away pi over 3, 5 pi over 3. We've solved this equation using one of the new identities which we can quickly derive from the one we already know.